Arpi showed you how we can handle the documents or the chemistry data on the web, and I would like to talk to you about another new product in ChemAxon, which mainly focuses on your local data, your local documents, and your local information in-house or maybe in your cloud drive. Let's start with a very tough question. How much money do you have to waste? Probably not millions of dollars, usually. At least I don't. I wish I had. So this leads us to the first problem I would like to introduce. Then why do we wasting it? Why do we waste that? Through an example, for instance, this is coming from a white paper 11 years ago, where it stands that, for instance, in an organization employing more than 1,000 knowledge workers spend more than $5 million on search in a year, which is a lot. But the problem is that a part of this money is just lost because many guys won't even find the information. I will show you later. And you can see that that's 11 years ago. So it's something what was true at that time, but what happened then? Some companies don't recognize that since then, which can be seen in the next slide here. On the left side, you can see the same white paper for 2005. Then the fourth biggest problem was the search for the companies, based on a survey including 1,000 workers from different companies. And that's another white paper from 2012, so 7 years later, and you can see that the search is still the fourth biggest problem. And on that chart on the right side, you can see that somewhere around 5 hours per week is spent on search by one particular guy in a company. And that's okay, but the other table here shows that 2.3 hours of this 5 hours is just wasting the time because you don't find the information. It's quite hard to recognize that because if you would like to find something, you start to search in your folders and so on. If you don't find them, you will just drop the whole topic maybe, but you don't recognize these 5 minutes or 10 minutes which were spent on something which was not successful. So let me introduce that through an example. For instance, this year there was a Drug Discovery Summit conference in the EU, and it had 40 presentations with more than 1,000 slides. Maybe 2 years later, you have a, I don't know, lunch with your colleague who said that he is working or she is working on an Azithromycinum structure or working with, and you just remember that you have heard that on the conference because somebody was speaking about that. And one obvious solution to send these slides over to your colleague is to find that one particular presentation. If you do that manually, and maybe we consider that you spend 2 seconds on each slide, which is, let's say, a guess, then it can go up to half an hour to find this particular presentation. Probably by that time you have guessed that our new tool, new solution is somehow something about searching, chemical searching, and that's true. So I would like to show you how you can achieve the same using this new tool called ChemLocator. The task is the same, find this particular guy, and the search time is just 149 milliseconds. And it seems to be much better than half an hour, of course, in worst case. So how we can do that? By the way, it's not that hard to do if you find the right way for the search, and in this case, it's not a magic. We have a lot of unstructured data in documents everywhere, and we just transform them to structured information and stored in a way which is searchable. And I would like to show you that in practice, how you do that. So we are looking for this guy, convert it to that name to drawing, and we have just found that Mr. Franco Lombardo spoke about that. You can see the search time there, and we have found this guy. But we were looking for something else. It's okay, it's a synonym what we found, but it's not exactly the same. And this is why we know a bit more than a simple free text search engine, because in a free text search engine it's not that easy to find synonyms. But using the ChemAxon's naming technology, that's available out of the box. For instance, in this specific case, this structure has this many synonyms. And if you try those in ChemAxon tools, we know all of them. Of course, it has even more. It's just some what I found and I wanted to list on one page. And this is why I think in this case you can use a free text search engine, but you need to know all the synonyms and look and search for them one by one, which is a very time-wasting process. Or you just delegate the work to, for instance, ChemLocator, who can do that for you out of the box. And it happens if you have 40 files, so it can you can find, maybe you spend half an hour and you will find this one presentation, but usually it's not the case in the companies. They usually have much more files, for instance 40,000 or even more in their company library, for instance. Maybe they are organized into folder, or maybe just stored, not well organized but stored, or maybe they could be even in the cloud. And that's something what we also considered in ChemLocator, and we have a solution for that, so I would like to show them. We have a server edition as well, which was exactly created for this purpose. If you don't have just local files on your computer, but you have a centralized store. I don't want to go through all of the differences here, just highlight the key differences. Why the personal edition is good for your local machine, it's a standalone application, by the way, used in your web browser, but you need to deploy it on your computer. The server edition is deployed centrally in a central server, and it handles the document permissions as well, and it has user account management and role management too. So another problem, for instance, if you work on natural products, maybe you have a task to find some similar products to quercetin, for instance, in this case, and the word similar is quite hard to translate to the query level in the case of natural products. So you need to find out something what you can help, what can help you. And one obvious choice is using some kind of ontology in this case. In this example, we are using freely available ontologies. And what we do is really nothing more than creating our query, Sparkle query, which can find those guys who share the quercetin as their same functional parent. And in the next example, those guys will be found. And it looks like in ChemLocator, then you need to specify the free text query, no structure query required, and under the hood, the ontology query run, you can find the quercetin, but you can find all those guys which I mentioned on the previous page, which has which share the quercetin as the functional parent. And the end user doesn't know anything about what happens in the background. The administrator and the ontology guys will create the Sparkle query in advance. But you can integrate the Sparkle, the ontology with ChemLocator too. Another problem is custom identifiers if you have corporate IDs. For instance, in this case, that's a real-world example as well without real names. This company A acquires company B and C, just as we heard yesterday with the IDPS who acquired the Treeman and Duck company long ago. So in this case, the company B and C and company A, they all have their own registration system in place, what is working, and they have the same structure registered under different IDs. And after these acquisitions, usually, or in many cases, the infrastructure is not merged, just made available to use for the others. So it could happen that all of the companies has documents in which they use their own IDs, but of course not the other company's IDs. So in this case, if you would like to find one structure in a document when it was represented just as an ID, it's quite hard because you need to know all the IDs. Or you can define that in ChemLocator. You can define a connection to these registration systems, and from this point, the search will consider all the IDs what the same structure has in the different systems. And in this case, I would like to show you through a video. We were looking for the histamine, we drew that, and we have found 3 documents, and that one, the first one was coming from the company C, the second one from the company B. You can see we found the IDs, and the last one is coming from the company A, because we also found that's an ID coming from the company A. And we started to integrate ChemLocator with other tools because technically we had 2 parts of the application. One is the component who does everything, and we have a UI which is simply HTML and JavaScript. And we provide the REST API, so it's more or less easy to integrate into any kind of applications. So if you think about that, then we can also, of course, offline discuss. And that's the way what we would like to continue in the future, to do more integration with more stuff. So one thing what I also would like to add here, so if you have, let's say, a big document set in-house, or articles, journals, anything, what you can't search chemically, or you can search, for instance, because you have a free text engine, but you feel you don't see the chemistry clear in the documentation. I hope the ChemLocator is something what can help you to see a bit more clearer in this topic. So that was all for today, what I wanted to share with you. So thank you, and I'm happy to take questions.
It's a fantastic product. Just wondering that, do you happen to have some time information, say, process about a million documents, and then in a single shot, and also incremental updates of it's a few thousand documents per day, that kind of timing information?
Indexing time of the documents. Actually, at the moment, we have only full indexing, which means everything needs to be re-indexed. But we just started to work on the, let's say, incremental indexing, which will scan through all the documents in the repositories and just handle those ones which has changed, maybe modified or added or removed or something. It takes a long time because, you know, we can go through the cloud drives, and we know also we index also the local drives and the file shares, and they are using different technologies, so the incremental indexing requires different approach if you consider the cloud or the local files. But it's on the table and we are working on it.
So we're like 1 week.
Sorry?
1 week. So for, let's say, run the job for 1 week, and I actually index static meaning numbers.
We have created some performance tests we did, and we indexed 60 gigabytes of documents, and it took 8 hours.
So yeah, structured search is really a nice product, right? So do you guys actually plan work with Google's, right? For example, you can enable Google search with a substructure, right? Because they have access to almost all the document, right? So that's kind of the big knowledge base.
So
right?
you mean integrating the ChemLocator into the Google Word?
Yeah.
It was a topic some months ago, but it's on hold now. So maybe yes, but not in the near future.